Welcome back. Today we are going to look at polynomials again, but this time under the topic the factor theorem. The factor theorem here enables us to factorize given polynomials. You're welcome. We're now looking at the factor theorem. Factor theorem. The factor theorem says that if f of minus a is equal to 0, then s plus a is a factor of the polynomial f of s. This implies that division by s plus a leaves a remainder 0. Similarly, if f of a is equal to 0, then s minus a is a factor of the polynomial f of s. As I said earlier in my introduction, this enables us to factorize a given polynomial and to also find the zeros of a polynomial. The zeros of a polynomial means the roots of that polynomial, the values of s that make that polynomial to be true. And that is what we mean by solving a given polynomial to get the values or the roots, whichever one is applicable. We shall now take a look at some examples on how to deal with polynomials and factorize a polynomial using the factor theorem. Example number 1. Factorize the polynomial px equal to s cubed plus 4s squared plus s minus 6. Here our attention is on factorizing the given expression. So our solution, we have here the triad and correction method, and the best way to do that is, let me write this, s cubed plus 4s squared plus s minus 6. Bring out the coefficient of s cubed. The coefficient of s cubed here is 1. Bring out the constant term here, and the constant term here is minus 6. Find the product of these two, and that will give you minus 6. The factors we will try, the factors of 6. You have your 1, you have minus 1, you have 2, you have minus 2, you have 3, you have minus 3, and of course you have 6 and you have minus 6. You have 6 and you have minus 6. These are the factors of minus 6. Now we are going to pick on this one, any of them, to try and see if it is correct. That's why I call it the trial and correct method. Not some call it trial and error method. Whichever way, the most important thing is that we will take up any of the values, the factors of minus 6. So here we go. Let's try s equal to 1. S equal to 1. If we try s equal to 1, we have 1 cubed plus 4, 1 squared plus 1 minus 6. This simplifies to be 1 plus 4 plus 1 minus 6. The value is equal to 0. If you add them and subtract 6, you have 0. Therefore, your s equal to 1 or s minus 1 is a factor. S minus 1 is a factor of the polynomial Ps. So, if s minus 1 is already a factor, we have gotten one factor. Since the degree of the polynomial is 3, we are going to have 3 factors. If the degree were 2, we will have 2 factors. If the degree is 1, of course, we have only 1 factor. So now, let's see what happens. One of the best methods is to, in case of where the degree is 3, is to now divide the polynomial by s minus 1 to bring it to a polynomial of degree 2. But we can still go on and try another value. So now we have gotten s equal to minus 1 as a factor. Let's try s equal to minus 2. S. So try s equal to minus 2. If you put your s equal to minus 2, what will happen? So your s equal to minus 2 will give you minus 2 cubed will give you minus 8. Minus 2 squared is 4. 4 times 4 is 16. Then you have again minus 2. Then you have again minus 6. If you add this together, minus 8 minus 2 minus 6 is minus 16. Plus 16 is equal to 0. Therefore, your s, if you bring it to this side, plus 2 is a factor. It's a factor of the polynomial ps. So we again take another factor because we need 3 factors. And the third one is, let's try s equal to minus 3. In this regard, you also have minus 3 cubed is minus 27. Minus 3 squared is 9. 9 times 4 is plus 36. Minus 3 is there. And minus 6. The result is also equal to 0. Therefore, you have s plus 3 is another factor of p of s. So eventually you have gotten the 3 factors that you need. So your answer, as far as the case is concerned, the factors of the if you are factorizing the polynomial, we now have our ps will now be equal to, the first factor is s minus 1, followed by s plus 2, followed by s plus 3. And that is the solution to the problem. Example number 2. Find the zeros of the polynomial ps equal to s cubed plus 4s squared plus s minus 6. Now, our solution. We have s cubed plus 4s squared plus s minus 6. What are the values of s that will make this expression to be equal to 0? In other words, we are solving the equation to get the values or the roots of s. Now to do this, you will recall that the coefficient of s cubed here is 1. And then the constant term here is minus 6. And finally the product of this will give us minus 6. Then we now have to try the following factors of minus 6. 1 minus 1, 2 minus 2, 3 minus 3, 6 minus 6. In trying any of these factors, any one that gives us 0 becomes a solution. Put s equal to 1. This will give you 1 cubed, which is 1, plus 1 squared is 1 times 4 will give you 4, plus 1 again, then minus 6. Let's see the result. If you add it together and subtract 6, is equal to 0. Therefore, s equal to 1 is a solution. Now again, we put our s, let's try something else. We put our s equal to minus 2. What happens? Minus 2 cubed is minus 8. Minus 2 squared is 4. 4 times 4 is 16. And then minus 2 again, and minus 6. Once again, this will give you 0. Therefore, our s equal to minus 2 is a solution, another solution. Then put or try s equal to minus 3. If you put that there, we will now have minus 27 plus 36 and minus 3 minus 6 again is equal to 0. Therefore, s is equal to minus 3 is a solution. So we have gotten the 3 values. Take note that the answer is s equal to 1 minus 2 minus 3. But also observe that after doing this, what exactly happened is your s minus 1 plus your s plus 2 and your s plus 3 is equal to 0. Is the polynomial Ps. Factorize. The polynomial Ps equal to this and is equal to 0 to solve the problem. So it is from here now you now say therefore s minus 1 is equal to 0 or s plus 2 is equal to 0 or s plus 3 is equal to 0. And when you solve this, you have your s equal to 1 or minus 2 or minus 3. But you need not to do this in case of an objective area or question. All you need to do is this process, then conclude by writing down the values of s, which are also the roots of that particular equation. So this is the solution. This is an explanation to tell you that you have factorized the polynomial, and from there you solve to get the values of s. Example number 3. If one of the factors of the polynomial p of s equal to s cubed minus 2s squared minus 5s plus 6 is s minus 3, find the other factors. Your solution? Take note here that you have been given one of the factors. So we have our s cubed minus 2s squared minus 5s plus 6. The best way now is to divide this by s minus 3. Because it is a factor, it means it will exactly divide this expression. So s into s cubed will give us s squared, leaving out with s cubed. This time this is minus 3s squared. You subtract, and that will be 0. Minus 2s plus 3s will give us s squared. Bring in minus 5s. Divide s squared by s to give you plus s. Multiply out with s squared, and that is minus 3s. And again, you subtract. That is s squared minus s squared is gone. Minus this, minus is plus, and that is minus 2s. Bring in your plus 6. Divide minus 2s by s to give you minus 2. Now multiply out is minus 2s, and that is going to be plus 6. Now at the end, you subtract again. This will be 0, this will be 0. So, we now have our polynomial Ps is actually equal to s minus 3 times what we have there, s squared plus s minus 2. Good. Now, from here we can factorize this. Remember quadratic equation. So we factorize this one, and to factorize it, that becomes s minus 1. Let's see, and then this is s plus 2. Good. If we factorize this, s times s is s squared. This is plus 2s minus s, which will give you s. This and this is minus 2. So bring this one down. This one also is your s minus 3. So all these are the factors of the polynomial. And remember, we have been given one of the factors, and we are told to find the other factors. Therefore, s minus 1 and s plus 2 are the other factors. These are the other factors.